The function f and g are both defined for this interval x greater than or equal -1, less than or equal 0 by fx equals 1 minus x squared. Meanwhile, gx equal e power 2x. The graph of f and g intersect at x equal a and x equals b, where a less than b. Find the value of a and the value of b. Okay. To find a and b, we have to start with this condition that fx equals gx. Okay, it means we have to find the value of x, but for me, I how I find uh, the value of a and b, uh, I have using my calculator, Casio graph 75. And when I sketch fx and gx, the graph like this. Okay, this is fx, and gx like this. Sorry. Gx like this. Okay, so this is 0, 1, while this coordinate point, okay, this is 1, and this coordinate point is, this is -1, sorry, -1 is x-axis, and this is y-axis, and this coordinate point is -0 0.916562, comma, 0.15991. But we're going to focus on this x, the value of x. So x is -0.916562. Okay, right. So it means x equals, okay, x equal based on this graph, fx and gx intersect at two coordinate points. The first one is -0.916562, and the second one is x equals 0. Yeah. Two intersection 1 and 2. According to the information that a less than b, so it means this one equals a equals -0.916562, and b equals 0. B, find the area of the region enclosed by the graph of f and gx. So we are going to calculate this area. Okay, by integral integral from minus 0.196562 to 0 of fx minus gx dx. So this is fx, and this graph is gx. This is gx. Okay, so it becomes this integral 0. Fx is 1 minus x squared minus gx is e power 2x dx. And we have to find first the integral of this function. 0. The integral of this expression is x minus 1 over 3x cubed minus half e power 2x. And if we substitute minus 0.916562 and 0 into this x, you're going to find the result is 0.2323985, or you can simplify or approximately become 0.24 0240. Consider the following bivariate data set. Okay, bivariate data set where P and Q element of integers, positive integers. That's the data. There are P and Q here. The regression line of y on x has an equation. This one, the equation. The regression line passes through the mean point, f for its x and f for its y. Given that f for its x equals 7, verify that f for its y equals 16. Based on these equations, I'd like to verify this. So f of y equals 2.1875 times 7 plus 0.6875. And if you calculate, this is 16. So it is correct. Next, B. I would like to use in this color. Given that Q minus P equals 3, this is the first equation. Find the value of P and the value of Q. According to this table, that Y, the sum of this Y data is 9 plus 13 plus P plus Q plus 21 over 5, 1, 2, 3, 4, 5. It equals 16, okay, because average of Y. So if 5 multiplied by 16, this equation being this 22 plus 21, 43. 43 plus P plus Q equals 80. 80 because 5 times 16. So it means P plus Q equals 80 minus 43, 37, and this is the second equation. True, first equation and second equation, we're going to determine P and Q. So I would like to write things like this. And then this one, Q plus P 37 plus, I need more space. Okay, so it is 2Q equals 40, and then Q equals 20 because 40 divided by 2, right? Now substitute Q equals 20 into this equation, P plus Q equals 37. So P plus 20 equals 37. So it means P equals 37 minus 20, 17. So this the result. P equals 17 and Q equals 20. The loudness of a sound L measured in decibels is related to its intensity I units by these equations. L equals 10 log 10 I times 10 power 12. Consider two sounds S1 and S2. S1 has an intensity of 10 power minus 6 units and a loudness of 60 decibels. S2 has an intensity that is twice that of S1. So S2 is twice than S1. S2 intensity. State the intensity of S2. The intensity of S2, I'd like to writing IS2. According to this information that intensity of S2 is 2 times or twice than S1. Intensity of S1, it means 2 times 10 power minus 6. Or we can writing 2 over 10 power 6 or 2 over 1 million. Okay. Or if we simplify, becomes 1 over 500,000 core units, of course, units here. Determine the loudness of S2. Loudness has equation like this. So it means the loudness of S2 part B. Loudness of S2, loudness has expression like this, 10 log 10 I times 10 power 12. That is one. And we're going to convert, we are going to substitute I equals 1 over 500,000 into here. It becomes 10 log 10, okay, 1 over, I would like to write in 5 times 10 power 1 to 5, okay, times 10 power 12. And we can simplify, becomes 10 log 10 wait, 10 power 12 over 5 times 10 power 5. Like this becomes 10 log and 12 minus 5, 7. So it is 10 power 7 over 5. Okay, like that. So it becomes 10 log. This is 10 over 5 times 10 power 6, like that. Becomes 10 log 2 times 10 power 6. And if you calculate it, you can find the result 63.0102, so on, and rounded to 63, 63 decibels. What else? The maximum loudness of thunder in a thunderstorm was measured to be 115 decibels. Find the corresponding intensity I of the thunder. So we're going to find intensity of the thunder if the loudness of the thunder is 115 decibels. Part C. So if 115 decibels, it means 10 log 10 I times 10 power 12 equals 115. So we're going to find I. Okay. So log 10 I times 10 power 12, 115 divided by 10 equals, yeah, 11.5. 11.5 according to the relation between logarithm rules and exponential rules, we can writing like this. I times 10 power 12 equal 10 is 10 power 11.5. The rule said like this. If log 10a equals b, a equals 10 power b. This the rule. Okay, so it means I equals 10 power 11.5 over 10 power 12. And it is 10 power 11.5 minus 12 is 10 power minus 0.5. And if you calculate, I have calculated this, the result is 0.3162277. Wait, I'm going to check once more. 10 power minus 0.5. Yeah, correct. Rounded to 0.316. That's the answer. Particle moves in a straight line such that its velocity v and v meter per second. This the velocity unit meter per second. A time t seconds is given by this function for t interval 0 to 2. Find the velocity of the particle at t equals 0. Right. This is the function. So if t equals 2, it means we can determine, sorry, this is 2 if t equals 2. Uh, this function becomes 1 plus e power minus 2 minus e power minus sine 4 radians. This is sine 4 radians. So sine 4 radians, yeah, minus sine 4 radians, I have uh, check on my calculator 0.7568 02495. So if you calculate this on your calculator, you're going to find the result minus 0.99611471085. Yeah. And approximately becomes minus 0.996 meter per second. Find the maximum velocity of the particle. Maximum velocity happening when the first derivative equals 0. So derivative of this function is 1. Derivative 1 becomes 0, and derivative of e power minus t is minus e power minus t. And velocity of this term minus e power minus sine 2t is plus 2e power minus sine 2t cosine 2t. Okay, equals 0. It means equals 0 here. Right. Now we are going to find t. If the derivative equals 0, it means you have to find t and substitute t into this function. On my calculator, I have sketched this graph to find t. This is t-axis and this is velocity axis. And the graph like this. Okay. And this is the intersection with the t-axis. The intercept point between this graph and t-axis are, this one is 0.40583 and 0, while this one is minus 0.6020. But according to this information, the interval t from 0 to 2. So we just use this uh, this one, the theory of t, this one. So t equals 0.4058. Why? Because of t interval 0 to 2. Okay. Now, if the maximum now substitute t equals 0.4058 into this function into Vt. Vt is 1 plus e power minus t minus e power minus sine 2t. So v 0.40583 is 1 plus e power minus 4 minus 0.40583 minus e power minus sine 2 times 0.40583. And if you calculate, the result on your calculator will be 1.8 to 1.1, sorry, 1.1, 1.18237.455. Approximately becomes 1.18, okay, meter per second, the unit. So this is the maximum velocity. Find the acceleration of the particle at the instant it changes direction. Okay, the particle changes its direction when the velocity equals 0. So it changes the direction when the velocity equals 0. And so we are going to find uh, the derivative first. Okay, so the derivative equals this one 0 and minus e power minus t, and then plus, yeah, just now plus 2e power minus sine 2t cosine 2t. Okay, we're going to find acceleration, and then now we have to determine t, how much t. I have create this graph, I mean, the derivative graph. This one, t, okay. And a graph like this. This the derivative, sorry. A graph like this. Okay. And the intercept point between this graph and t-axis on 1.6 1.65841 and 0. So T equals 1.65841. 5841. Now substitute T into this function. So 1.65841 E minus 1.65841 plus E power minus sine 2 times 1.65841 and multiply cosine 2 times 1.65841. And if you calculate, the result will be minus 2.5348284, I mean 841, and approximately becomes minus 2.53. So acceleration is 2.53 meter per second squared. Minus, it means this is deceleration. Yeah. The type of acceleration is deceleration because it has minus. Consider a random variable x such that x binomial distributions of n and 0.25. Determine the least value of n such that probability x greater than 1, greater than or equal 1, greater than 0.99. Okay, this is the binomial distribution problem. So through this information that we can state that p equals 0.25 and q equals 1 minus 0.25. It is 0.75. Okay. The first I'm going to find probability of x equals 0. Probability x equals 0 is combination n, 0, is 0 of n, and then p is this one, 0.25 power 0, 0. This one, because this 1 minus p, so it is q, 0.75 power n. And this value is 1, so 1 times 0.75 power n, it is 0.75 power n. Now this one, probability x greater than or equal 1 greater than 0.99, we can write as 1 minus probability x equals 0 greater than 0.99. Okay, so minus probability x equals 0, it is 0.99 minus 1. So minus probability x equals 0 greater than minus 0.01. Okay. Or probability x equals 0, change the direction less than 0.01. Okay, let's refine n. Sorry, we have to substitute this one because probability x equals 0 is 0.75. 0.75 power n less than or equal 0.1. Now let's refine n. Okay, find n. I need more space. Okay, find n through this way. 0.75 n equals 0.01, right? We can set like this and log using logarithms. 5, it is log 0.01. So n equals log 0.01 over log 0.75. And if you calculate, the result is 16.0078455. This is n. Now let's recheck. Let's check the area. Okay, the solutions area. Okay, this is the strike line, number line. Okay, and 16.0078455. We're going to check which area is the solutions area. Okay, whether the left side or the right side of 16.0078455. And we have to check one by one, left and right. At left, I will taking a number less than 16, that is 15. Okay, if n, okay, when n equals 15, according to this inequality, it will be 0.75 for n, power 15, I mean, okay, power 15. And if 0.75 power 15, I have calculated it is 0.0563, and this number greater than 0.01. So if you compare with this statement, this inequality, that if n equals 15, this is incorrect. Okay, because this number greater than 0.01. We have to find which area with the number with n. If we substitute into here, the result is greater than is less than 0.01. Okay, 15 is a number less than 16. Now I'm going to use another n, and n equals 20. 20 is a number at right side of 16. Okay, so if 0.75 power 20, the result is 0.00317. It is less than 0.01. Okay, less than, if you compare with this statement that 0.75 power n less than 0.01, so this is correct. If n equals 21, so correct that 0.00317 less than 0.01. So the solutions area at the right side, please. Okay, or the conclusion n greater than 16.0078455. This is the answer. The volume of a spherical bubble increases at a constant rate 5 centimeter cubed per second. The initial volume of the bubble can be assumed to be zero. Initial volume. Find the rate in centimeter per second at which the radius of the bubble is increasing when the volume of the bubble is this one, 20 centimeter cube. Underlined already. Okay. As you know that the volume of the spherical volume is on the formula 4 over 3 pi r cubed. And according to this information that the volume is 20. So I like to arrange this formula if R is the subject. It's going to be R cubed equals 20 times times 3 over 4 pi, like that. Okay, or 20 over pi times 3 over 4. And then 20 by 4, 5, 15 over pi. Or R equals 15 over pi power 1 over 3. That is R. Or you may convert also into decimal. And the next step, I'm going to find dr dt, but according to chain rule, I'm going to using chain rule that differential of dphi to dt, dphi dt, it is dphi dr times dr dt. If dr dt is the subject, it will be dr dt equals dphi dt times dr dphi. Okay, so this term moves to the last. Okay, so this one. And next, we're going to find the RDV from this equation that V equals pi over 3, 4 over 3 pi r cubed. So the VDR is 3 times 4 over 3, 4 pi r squared. And if the RDV, the opposite, 1 over 4 pi r squared, like that. So it means if the R dt can writing dv dt times dr dv, this one over 4 pi r squared. This one, or 1 over 4 pi r squared dv dt. Now, when dv dt equals 5, according to this information, in places becomes the constant rate 5. We can substitute dv dt into can 5. We can substitute 5 into dv dt, and dr dt equals 1 over 4 pi r squared times 5. Okay, so it is 5 over 4 pi r squared, like that. Okay, so and next, r is, we already got r, this one, 15 over pi power 1 over 3. Substitute r into this equation. I'm going to move here. So the r dt equals 5 over 4 pi times 15 over pi power 1 over 3 over 2, or 5 over 5 over 4 times, this is 22 over 7, because pi, times 15 over 22 over 7 power 2 over 3 becomes 5 over 88 over 7 times 15 times 7, 105 over 22 power 2 over 3. And the result, if you calculate, the result will be 0.1400305. This is on my calculator, rounded to 0.140, and the unit centimeters per second. That is the result. Number 7, the curve y equals 4 ln x minus 2 for y interval 0 to 4 is rotated 360 degrees about the y-axis to form a solid of revolution. Y-axis, it means if y-axis we have to change these equations, x becomes the subject, okay? Because rotated on y-axis. Find the volume of the solid form. So these equations, y equals 4 ln x minus 2, this is, y is a subject. Now we are going to change, becomes x is the subject. So it means this equation becomes, we can arrange becomes y over 4 equals ln x minus 2. And according to the rule, the learn rule, that we can writing this equation as x minus 2 equals e power y over 4, or x equals e power y over 4 plus 2. So x becomes the subject. Now let's calculate the volume. The volume, I'm going to move here. No, not here. Volume equals pi times pi AB and x squared dy if rotated on y-axis. Okay, so it means becomes pi 0 to 4, because the interval of y 0 to 4, and this one x equals e power y over 4 plus 2 e power y over 4 plus 2 squared dy. Or we can expand 0 to 4 e power, this one becomes y over 2 times 2, 4 e power y over 4 plus 4 dy. And after that, find the differential, the integral of this expression. And the integral is 2e power y over 2 plus 16 e power 1 over 4 y plus 4y. And after that, substitute 4 and 0 to this expression. And if you substitute 4 and 0, it becomes pi times 2 e power 2, 16 e power 1, and then plus 4 times 4 minus, substitute 0, to e power 0, 16 e power 0 plus 4 times 0. Pi times this is 2e squared, 16e plus 16 minus this one 2, okay, 2, and then this one 16 pi 2e squared plus 16e, okay, minus 2. Or you can factorize, becomes 2 pi e squared 8e minus 1. Now, if you substitute this pi is 22 over 7 times sorry, it becomes 44. 44 e minus 1. If you substitute, if you calculate on your calculator, you can find the result as 176. I already calculate this 0.77 rounded to 177. Next, let z equals 1 plus cosine to theta plus I sine to theta, where theta interval from minus pi half to positive pi half. Show that argument z equals theta. A part 1. A part 1, z equals 1 plus cosine 2 theta plus I sine 2 theta. Z is a complex number, which real part is 1 plus cosine 2 theta, and imaginary part is sine 2 theta. So argument of a complex number determined by this one, argument z, okay, argument of this complex number z, it equals tangent power minus 1 of y over x. This is the rule of argument of a complex number. Okay, y equals, this is x and this part is y. So it becomes tangent power minus 1. Y is 1 sine 2 theta, and x 1 plus cosine 2 theta. According to trigonometrical identity, that sine 2 theta equals 2 sine theta cosine theta. Meanwhile, 1 plus cosine 2 theta equals 2 cosine squared theta, or 2 cosine theta cosine theta. So this equation okay, based on this information, accordingly, this expression we can writing as 2 sine theta cosine theta over 2 cosine squared theta. There are cosine theta, two double cosine theta here. Okay. Divide equals 1, divide equals 1. So sine theta cosine theta becomes tangent power minus 1. This tangent power minus 1. Same with arc tangent or inverse tangent. Tangent theta. Argument z. So it means argument z is equals theta, because inverse tangent of tangent. Okay, with interval theta minus pi half to plus pi half, according to the information. Part 2, modulus C equals cosine theta. Z equals 1 plus cosine 2 theta plus I sine 2 theta. Just now I have stated that x equals 1 plus cosine 2 theta and y equals sine 2 theta. So modulus z is x squared plus y squared. Or if we substitute these expressions into here, modulus will become 1 plus cosine 2 theta squared plus sine 2 theta squared. So modulus z equals 1 plus 2 cosine 2 theta plus cosine squared 2 theta plus sine squared 2 theta. According to the grammatical identity that cosine squared 2 theta plus sine squared 2 theta is equals 1. Yeah. Okay. I need more space. So modulus C equals 1 plus 2 cosine 2 theta plus 1, because this part is 1. So modulus Z is 2 plus 2 cosine 2 theta. Okay. According to trigonometrical identity, that 2 cosine, that 1 plus, wait, that 1 plus cosine 2 theta equals 2 cosine squared theta, or 2 cosine theta squared. So we can write in this part as 2 times 1 plus cosine 2 theta. So we can apply this rule, trigonometrical identity becomes 2 times 2 cosine squared theta. So it's going to be 4 cosine squared theta. Square root 4 is 2, and square root cosine squared theta is cos theta. So proof that modulus z equals to cosine theta. Okay. Proof. All right, next. Part B, hence or otherwise, find the value of theta such that argument c squared equals modulus c cubed. Part B. argument c equals theta. Argument c squared, it equals argument z times z, or argument z plus argument z, or 2 argument z. Okay, so argument z equals theta. It means argument c squared equals 2 theta. This is the first equation. Next, argument, if argument c squared equals modulus c cubed, it means 2 theta equals 2 cosine theta cube. Okay, based on this information, so I would like to tell this argument 2 actually. So argument from sorry, not equation 2. So equation 2 combined with equation 1 becomes like this, right? Okay, it's going to be 2 theta, 8 cosine cube theta divided by 2 becomes theta equals 4 cosine cube theta. And now we're going to find theta. If okay, let x equals theta, because I would like to find the solutions on Cartesian diagram. So if theta in radians, okay, so y becomes x minus 4 cosine cube x. And I have sketched on Cartesian diagram y x with theta in radians, and the graph like this. Okay, and the intercept point here is on my calculator. Casio graph, Casio graph 1, Casio graph 75, 0.9132 so on, 0, and here the maximum is 3.2256 on, 7.18 so on. So x or theta equals 0.9132 on radians, or 0.913, of course, in radian. Consider the curve y equals x minus 4 over ax squared plus bx plus c, where a, b, and c are non-zero constants. The curve has a local minimum point at 2, 1 and vertical asymptote with equation x equals 1. Find the values of a, b, and c. The curve function is y equals x minus 4 over ax squared plus bx plus c. If this function's true, through 2, 1, it means it is true x equals 2 and y equals 1. If we substitute into this equation, into this function, it will be 2 minus 4 over 4a plus 2b plus c equals 1. If denominator times 1, this equation becomes 4a plus 2b plus c equals 2 minus 4 minus 2. This is the first equation. Next, this curve has a local minimum point at 2, 1. Local minimum point, this is important thing. The local minimum we got through dy dx equals 0. If y equals u over v, it means dy dx equals v du minus u dv over v squared. Based on this rule, we can determine dy dx or derivative of this function. So dy dx v times du. This is v times and derivative v this one, derivative of u. So ax squared plus bx plus c, derivative of x minus 1 is 1, x minus 4 is 1, and then minus x minus 4 multiply 2ax plus b over v squared. Ax squared plus bx plus c squared equals 0 based on this rule. Okay, so if denominator times 0, this equation becomes ax squared plus bx plus c minus x minus 4 times 2ax plus b equals 0. Right. Okay, and local minimum coordinate point at 2, 1. So it means x equals 2. If we substitute x equals 2 into this equation, it becomes 4a plus 2b plus C minus 2 times 4A plus B equals 0. 4A plus 2B plus C minus minus becomes plus 8A plus 2B equals 0. Becomes 12A because 4A and 8A next to B and 2B, 4B plus C equals 0. This is the second equation. And the next focus is vertically asymptote. Vertically asymptote. Okay. The vertical asymptote is x equals 1. If you look at this function, this is a rational function. Y is a rational function. So a rational function asymptote, okay, a rational function asymptote is especially the vertically asymptote, we can determine through denominator equals 0. So if y equals x minus 4 over ax squared plus bx plus c, this is the rational function. So how to find the vertically asymptote? We can determine vertically asymptote through a rule, and the rule says that denominator equals 0. It means ax squared plus bx plus c, it should be 0. Okay, next. And vertical asymptote x equals 1. So it means we can substitute x equals 1 into this equation. So it means it becomes a plus b plus c equals 0. Because this is a times 1 times 1. This is squares. Okay, so that's why it becomes a plus b plus c equals 0. And this is the third equation. Now, through the first equation, second equation, the third equation, we can determine the values of a, b, and c. I'm going to look at the first equation. The first equation for a plus 2b plus c equals minus 2. Okay. For a plus 2b plus c equals minus 2. This is first and second equation. Okay. And the second equation is 12a plus 4b plus c equals 0. Now we're going to eliminate c equals 0. And 4 minus 12 is minus 8a minus 2b equals minus 2. Okay? Because minus 2 minus 0 equals minus 2. Okay, next. And after that, the first and the third equation for A plus 2B plus C equals minus 2. And the third equation, this one, yeah, A plus B plus C, sorry, A plus B plus C equals 0. Okay, eliminate C. This is 3A plus B equals minus 2. This is the fourth equation, and this is the fifth equation. Now, between the fourth equation and the fifth equation, we can determine the next value. Minus 8A minus 2B equals minus 2. 3A plus B equals minus 2. Okay. This is times 1 and times 2. We are going to cancel, to eliminate B. Becomes minus 8A minus 2B equals minus 2. Minus, sorry, 6, not minus, positive 6A, because 2 times 3 plus 2B minus 4 plus, because we are going to eliminate 2B, this is minus 2A equals minus 6, and A equals minus 6 over 2 over minus 2 equals 3. Okay, A equals 3. Now substitute. Substitute. Substitute A equals 3 into these equations, into fifth equation. 3A plus B equals minus 2. If A equals 3, it means 3 times 3 plus B equals minus 2. Wait. Okay, this one. This is 9, so B equals minus 2, minus 9. B equals minus 11. Okay. A equals 3, B equals minus 11. Now we're going to substitute A equals 3, B equals minus 11 into, I'm going to substitute into the third equation. Third equation, A plus B plus C equals 0. Wait, I need more space. So it means 3 minus 11 plus C equals 0. 3 minus 11 is minus 8 plus C equals 0. That means C equals 8. So A equals 3, B equals minus 11, and C equals 8. That's the solution. A shop sells chocolates. The weight in kilograms of chocolates bought by a random customer can be modeled by a continuous random variable x with probability density functions f defined by this function. Find the mode of x. The mode of x we can find through maximum or minimum point of a graph or of a function. So how to find the maximum and minimum point of a function? We need to state that the first derivative equals 0. Okay, so it means the first derivative of x, it should be 0 to get maximum or minimum point. Okay, now if fx equals, wait, I forgot this function, equals, this is fx, 6 over 85 times 4 plus 3x minus x squared with interval x 0.523, right? So if we calculate it, it becomes fx. Wait, I'm gonna writing here. Okay, fx becomes 6 times 24, 6 times 4, 24 over 85 plus 18 over 85x minus 6 over 85 x squared. I like to clean first. Okay, next. So we need to find the derivative of these functions, and the derivative of this function is this is becomes 0, and this one is 18 over 85. This one is 12 over 85 x equals 0 based on this statement, this rule. That maximum point, to get maximum point and minimum point, we have to find, we have to determine the first derivative equals 0, right? If 18 over 85 minus 12 over 85 x equals 0, we can determine x. How to determine x? Times 85 first. Okay, all terms, and it becomes 18 minus 12x equals 0. So it means 12x equals 18, and x equals 18 over 12. Divide by 6, by 6, 3 over 2. This is x, or 1.5 kg. Okay, next, part B. Find probability x greater than or equals 1, less than or equals 2. Okay. Yeah, because this problem about probability density function. Okay, B, the probability x greater than or equal 1, less than or equal 2. We can find this probability through integral 1 to 2, because it is the interval 1 into 2 of fx, okay, dx. It means the integral 1 to 2 fx is, wait, I have to check first. Okay, 6 over 85. 6 over 85 times 4x times 4. But I have to check once more. Plus 3x minus x squared. Like that. Or 6 over 85. 1 to 2. And integral of these expressions is for x plus 3 half x squared minus 1 over 3 x cubed. Okay, and after that, substitute 2 and 1 into this expression. Becomes 6 over 85 times 4 times 2 3 halves times 2 squared 1 over 3 times 2 cubed minus 4 times 1 plus 3 half times 1 squared minus 1 over 3 times 1 cubed. And if you calculate, you can find the result is 37 over 85. Or in decimal number is 0.4352, so on. Or rounded to 0.435. Next, part C. Find the median of x. To find the median of x, see, through integral as well, okay, 0.5, because the interval x from 0.5 to 3, this is the interval. Now, the median, the median position between 0.5 and 3. So I would like to write here the median here, okay, of fx is equals fx dx equals 0.5 or half, because median, okay, 0.5 of all data, right? And it becomes 0.5 to median. Fx is, 6 over 85, f plus 3x minus x squared dx, that equals half. I'm going to using half as well, this one half. Okay, next. Now we're going to find the integral of this expression. Okay, so integral of that expression is 6 over 85 for x plus 3 half x squared 1 over 3 x cubed. okay, equals half. As we substitute m and half. If we substitute m and half, it's going to be 6 over 85 4m plus 3 half m squared minus 1 over 3m cubed minus 4 times half, 2 plus this is 1 over 4. It means 3 over 8 minus 1 over 3 times 1 over 8, 1 over 24. Okay, was half. Or 4m plus 3 half m squared minus 1 over 3 m cubed minus 2. Wait, this is 24. 7 over 3. Yeah, I have calculated this. And half times 85 over 6. 85 over 12. Okay, this is 85 over 12. Okay, so 4m plus 3 half m squared minus 1 over 3 m cubed. This is times 4 equals 12 times 4, 28. So 85, 28 over 12. 4m 3 half m squared minus 1 over 3 m cubed, 85, oh, plus, not minus, because this is minus 113 over 12. Okay, through graphical method or a numerical method, I have find m, the roots of this equation. The roots are minus 2.902597 1.68701 and so on, 5.7335, so on. But the interval of x, okay, the interval of x 0.5 to 3. That's the interval. That means m, the median, the maximum is 3. Okay, impossible 3 because a median position between 0.5 and 3. So receive this number. That means median equals 1.68701 rounded to 1.69. This is median. What else? The shop sells chocolate to customers at $25 per kilogram. However, if the weight of chocolate bought by a customer is at least 0.75 kilograms, the shop sells chocolate at a discounted rate of $24 per kilogram. Okay. Find the probability that a randomly selected customer spends at most $48 probability. Okay. Right. Part D. The probability we can determine through integral 0.5 to 2. Okay. Yeah, if you look this, the question and information that find the probability that a randomly selected customer spend at most $48. $48, it means 24 times 2. Okay. Because chocolate at this kind of rate, 24 kilograms. Okay. Fx, dx. Okay, so it becomes 6 over 85, 0.5, 2, and the integral is 4x plus 3 half x squared minus 1 over 3x cubed. Okay, and if you calculate this, substitute 2 and 0.5, okay, it becomes like this, 8 plus, this is 4, okay, 4 times 3, 12, 6, yeah, 6, minus 1 over 3, 8 over 3, okay, and then minus 4 times 0.5, after that minus 3 half 0.5 squared, 1 over 3, 0.5 cube. So if you calculate, the result is 0.63529. You may calculate rounded to 0.635. Next part E. Find the expected amount spent per customer. Give your answer correct to the nearest cent. Okay. Yeah, we are going to find how much money the customer spent, okay, to for chocolate, right? So it's gonna be, I would like to start from, yeah, the shop sell chocolate, the shop sell uh, chocolate, okay, uh, yeah, $25, okay, per kg, okay, and then the sales discounted this discounted rate for chocolate, that is $24 per kg. If X is amount of chocolate in kg, it means this becomes 25x and this is 24x. And every customer spent integral 0.5 to 0.75. Why 0.75? Because if you look the question here, okay, uh, at least 0.75. So they have to buy chocolate uh, at least 0.75, okay, at the shop. Okay, so they have to buy 0.75. Okay, and they will get discount. Next, so okay, 0.75, 25x, have x, okay. If they bought 0.5 to 0.75, there is no discount, the special price, I mean. But if they bought 0.75 to 3, okay, so they will get the special price is $24. Okay, so the discount given just for those customer bought chocolate from 0.75 kg to 3 kg. Okay. Uh, okay. And we can calculate this 25, 0.5, 0.75 x times 4 plus 3x minus x squared dx 0.75 to 3, 24 here, x 4 plus 3x minus x squared dx. Okay. And it becomes, oh, sorry, there are actually 6/85 here. Plus 24 times 6/85. It's going to be 150/85, 5, 0.75, and the integral is 2x squared. 2x squared, it means x cubed. Okay. Minus, this is x cubed, it means 1/4. X power 4. And this one, 24 times 6, 144/85. 0.75 to 3. And the integral is same like this expression. 2x squared plus x cubed minus 1/4 x over 4. And if you calculate this part, I have calculated this part, uh, result is 1.5148 so on. And if you calculate this part, substitute 3 and 0.75 into these expressions, you can get the result 39.4428 so on. And the result is 40.9576. Yeah, so on, rounded to 40 96.96 in 2 cents. Okay, $40 96 cents. So the conclusion, okay, every customer spends uh, spend money $40 96 cents for chocolate. Yeah, this the solution. A rotating sprinkler is at a fixed point S. It waters all points inside and on a circle of radius 20 meters. When S is 14 meters from the edge of a path which runs in a north-south direction, the edge of the path intersects the circles at points A and B. This information is shown in the following diagram. This diagram. Question A. Show that AB equals 28.57. Correct to 4 significant figures. Okay. Right. Part A. I will create this triangle, rectangle triangle. This is S, and this is A, point S, point A. I'm gonna check the direction first. Sorry, the distance, I mean, 20 and 14. 20 and 14. So it means we can determine if this point is M, we can determine AM through Pythagoras. So AM equals the root 20 squared minus 14 squared, and it is 400 minus 196. So it is 204. Or we may simplify becomes 2 square root 51. That is AM. Next, it means we can determine AB. Because the triangle like this, triangle like this. S here, A here, B here, M here. If AM is 2 square root 51, it means AB equals 2 times 2 square root 51, because AB equals 2 times AM, 4 square root 51. And if you calculate, the result is same with this one, 28.57. That's one. The sprinkler rotates at a constant rate of 1 revolution every 16 seconds. So 1 revolution uh, the 1 revolution occurs every 16 seconds. So that the sprinkler rotates through an angle of pi over 8 radians in 1 second. Pi over 8. Part B. The sprinkler rotates an angle 2 pi for every 16 seconds. So 2 pi over uh, amount of rotations is equals 16. Or we can arrange becomes n equals 2 pi over 16, or n equals 1 over 8 pi, or n equals pi over 8. Based on this information, of course, in radians. Let t seconds be the time that a bee is water in its revolution. Find the value of t. Okay, one rotation, it's part C. One rotation is uh, to theta, the angle. If theta is equals the angle of uh, ASM, if I'm mistaken, from this triangle ASM. Doesn't know I have explained this. Okay, and this angle is theta. It means 2 theta. The angle of 2 theta is angle of ASB. Okay. Yeah. So it means 2 theta over n equals 2 theta over t, like this, right? So from the previous explanations, I have explained that 2 pi, 2 pi over 16, it equals n. It means 2 pi over 16 equals 2 theta over t. But we are going to find theta first, and we have to convert theta into radians. Okay. Uh, I'm going to using cosine. cosine theta equals, I need this information. This, if not mistaken, this is 20. This is 2 square root 51, and this is 14. Okay. Cosine theta is 14 over 20, or 0.7. That means theta is arcsine 0.7, and it is 45.572,996. That is angle ASM. Next, it means 2 theta, or angle ASB, is 2 times 45.572,996. I need more space. 2 theta, 2 times this number, and 2 theta is 91.145,992. Okay, 992. I have to check on my calculator. And if you convert into radians times 3.14 over 180, in radians becomes 1.589, I mean 1.589991194. Okay, in radians. This is radians. So let me look this formula. If you're gonna find t, how we gain t? If t the subject of this formula, it means t equals 16 over 2 pi times 2 theta. But 2 theta should be in radians. So it's going to be 16 over 2 pi times this number, 1.5899, so on. And the result is, I have calculated this, 4.0509, rounded to 4.05 seconds. Next, consider 1 clockwise revolutions of the sprinkler. At t equals 0, the water crosses the edge of the path at A. At time t seconds, the water crosses the edge of the path at a movable point D. So from point A to point D. Move from point A here to point D here. At t equals 0, water crosses point A, okay, which is a distance d meters south of point A. So A to D is d meters. Let alpha equals angle ASD, and beta equals angle SAB, where alpha and beta are measured in radians. This information is shown in the following diagram. This diagram, I think clear. Write down an expression for alpha in terms of t. On my previous explanation, there is an information regarding rotations of sprinkler. This one, the sprinkler rotates at a constant rate of one revolutions every 16 seconds. Okay. The sprinkler rotates through an angle of pi over 8 radians in 1 second. In every second, sprinkler rotates pi over 8 radians. Okay. So I would like to write in here. Okay. Every second, sprinkler rotates sprinkler rotates through pi over 8 radians. So it means alpha equals pi over 8 times t, because every second, the time every second and in t. Okay, from A to D, that is t. So when water crosses at A, that is 0, and with this, uh, when water when water crosses A, that is beginning the 0, and until D here, as long as this is T. Okay, T second, right? As here, T second, and the distance is D. Okay, but time is T. So alpha equals pi T over 8. So it's supposed to be not like this, but be like this. I would like to fix this one. This one, the line. Okay, D here. The distance symbol in D and the time symbol in T. Okay, next. It is known that beta equals 0.7754 radians, correct to four significant figures. By using the sine rule in triangle ASD, show that the distance D at time t can be modeled by like this equation. Okay. Based on this triangle, and according to sine rule, that we can state that, okay, on this triangle, that this is 20 meters, that d over sine alpha equals 20 over sine sine angle, so an ADS. So we can find D through this equation, that D equals 20 over sine angle ADS times sine alpha, or D in T, 20 sine alpha. Yeah, with alpha equals, like to writing here, alpha equals pi T over 8 over sine angle ADS. Okay, I need more space. Right. So dt is 20 sine pi t over 8 over sine uh, angle ADS. Angle ADS. Okay. Angle ADS equals, okay, if you look this triangle, angle ADS, this angle, right, this angle ADS. Angle ADS is this is angle beta. Okay. Angle ADS it is equals. I will write angle ADS. I will write here 180 minus alpha minus beta, or 180 minus alpha minus 0.7754 according to this information. Okay, so it means angle ADS equals 180 minus uh, this one. Okay, but we have to convert this into radians. Into radians is 3.14 minus 0.7754 minus alpha. So angle ADS equals 2.3646 minus alpha. So I'd like to writing here sine 2.3646 minus alpha. Okay, so dt equals, and more space, dt equals 20 sine pi t over 8 over sine rounded that here 2.3646 rounded to 2.37. So this is 2.37 minus alpha. True. Okay, so same with this model. Next, a turtle walks south. A turtle walks to south along the edge of the path. At time t seconds, the turtle distance g meters south of A can be modeled by this function. At t-cosecond, state how far south the turtle is from A. So wait, if t equals 0, g0, it means g0 is 0.050 squared plus 1.1 times 0 plus 18. So it is 18 meters. Direction to south or to downwards. Let W represent the distance between the turtle and point D at time t seconds. Use the expressions for gt and dt to write down an expressions for W in terms of t. Okay. G part 1. So W equals gt minus dt. Okay. According to information that W represents the distance between the turtle and point D at time t seconds. So the turtle from this is point A, this is point D. Okay, so the turtle moved to downward, for example, until GT here. Okay, so W equals GT minus DT here. Okay, so it means that W equals 0.05 t squared plus 1.1 t plus 18 minus this is gt. dt is 20 sine pi t over 8 over sine 2.37 minus alpha, or we can write things like this: W equals 0.05 t squared plus 1.1 t plus 18 minus 20 sine pi t over 8 sine 2.37 minus alpha, like this one. Next, part 2. Hence, find when and where on the path the water first reaches the turtle. Okay. Right. So it means GT or GT equals DT. Okay. When GT equals DT. Right. Yeah. Okay. When and where on the path the water first reaches the turtle. So the water reaches the turtle when GT equals DT. If GT equals DT, it means W equals 0. Because actually this one, just now I told you, just now I have written that uh, W equals GT minus DT. So if W equals 0, it means GT minus DT equals 0. Okay, so this is if GT minus DT, it equals 0. Or W equals 0. W equals 0, it means uh, 0.05 t squared plus 1.1 t plus 18 minus 20 sine pi t over 8 over sine 2.37 minus alpha, it equals 0. Okay. Okay. I need more space. So 0.05 t squared plus 1.1 t plus 18 minus 20 sine pi t over 8 over sine 2.37 minus alpha equals 0. On my calculator Casio graph 75, uh, I have sketched the graph on my calculator. Change becomes a functions and then sketch the graph. If this is w equals 0.0 t squared so on. So when I sketch the graph, this is w axis and this one t axis, and the graph like this. Okay, this is 0 and 20, while this one is 3.34807124107 and 0. Okay, and there is the second line also like this one, and this is 12.7654932399898, okay, 9898 comma 0. Okay, so it means t equal this number 3.3488 so on, and round it to 3.35, 34349, 4 significant figures, and as well t equal 12.7765, rounded to 12.78, okay, 4 significant figures. So it means GT, okay, GT is 0.05 t squared plus 1.1 t plus 18. Now we're going to substitute each one. Okay, if you substitute 3.349, it becomes 0.05 times 3.349 squared plus 1.1, 3.349 plus 18 And if you calculate, the result will be 22.25 meters. And the direction and where the direction to south. To south is downwards. So when 22.25 and where at 22.25 when to the direction is to downwards or to south. Consider the differential equation dy dx minus y cosecant to x equals square root tangent x, where x interval 0 to pi half and y equals pi over 4 at x pi over 4. Use Euler's method with step length pi over 12 to find an approximate value of y when x equals 5 pi over 12. Give your answer correct to three significant figures. Okay. So dy dx minus y cosecant to x equals square root tangent x. Okay. Y equals pi over 4 at x pi over 4. Right. So we can arrange this equation, this differential equation becomes dy dx equals y cosecant to x plus tangent x. According to Euler's method, that xn plus 1 equals xn plus pi over 12. This according to Euler method. And y, yn plus 1 is equals yn plus pi half pi over 12 dy dx. Right. If n equals 0, so x1 is pi over 4. So this one. And it means y1 is according to this rule that y1 equals y0 because n equals 0, y0 plus pi over 12 pi over 4. So this is pi over 4 actually. This is pi over 4. This one pi over 4 times cosecant to x, actually cosecant to x. This is dy dx, dy dx this one. So this is y, so cosecant to x plus square root tangent x. So it's gonna be pi over 4 plus pi over 12 pi over 4. Cosecant to x is 1 over sine 2x plus square root tangent x. So it becomes pi over 4, okay, plus pi over 12 times pi over 4 sine 2 times x is pi over 4, pi over 12, I mean, pi over, sorry, pi over 4, this one, x pi over 4. This one, x1 pi over 4. Okay, so plus square root tangent pi over 4 comes pi over 4 pi over 12 times this is pi over 4 times sine. This is sine 2 times pi over 4. This is 1. Okay, plus the root tangent pi over 4 as well. 1. So it becomes pi over 4 plus pi over 12 times this is pi over 4 plus 1. Okay. Okay, and if you calculate, I have calculated this, and the result is 1.2534013605. You may check on your calculator. That is y1. Next, y2. But we have to find first if n equals 1. If n equals 1, so it means x1 plus 1, x2, it means x2 is pi over 4 plus pi over 12, okay? And it's supposed to be plus pi over 12. So according to the information, and this one is times 3 for 12 pi over 12 pi over 12 5 over 12 pi. It means y2 is y1 times pi over plus pi over 12, okay, plus y 1 over sine 2 5 pi over 12 plus tangent 5 pi over 12. And it is this one 1.25 on this one plus pi over 12 y pi over 4 1 over sine 10 over 12 pi plus the root tangent pi over 12 in brackets. Next, I need more space. And if you calculate, I have calculated this, the result is 1.93190 on. You may check on your calculator. Rounded to 1.93. So y is 1.93. Next, part D. Show that the x of half-length cotangent x equals minus cosecant to x. Okay. Right. Part B. Cotangent x, I will start with cotangent x, is cosine x over sine x. Now let u equals cosine x over sine x. This is cotangent. Yeah. Our questions is cotangent. Cotangent x. So this is actually cotangent. Okay. Cotangent x, cotangent x. Same. Cot or cotangent x. Okay. So wait. Now let W, I would like to find the UDX. But if U, because this is a difference U cosine X, it means the U equals minus sine X. If phi equals sine X, so the phi equals cosine X. The U, the X, we can get to this formula P du minus U dphi over phi squared through this formula. Okay, so du dx du dx is phi sine sine x minus sine x cosine x over cosine x squared. Wait. Okay. So du dx is minus sine squared x minus cosine squared x over cosine squared x, or minus sine squared x in brackets cosine squared x over cosine squared x. So this is minus 1 over cosine squared x. Okay. Yeah, from this one. Sorry, this is phi actually sine. Sorry, I'm wrong. This is sine. It's supposed to be this is sine. not cosine. This is sine x. Okay, sine square x. Sine squared x is sine minus 1 over sine squared x. So du dx equals minus 1 sine squared x. Right. If y equals half ln cotangent x, and if cotangent x is u, it means half ln u according to this one, that u cosine x over sine x, or u equals cotangent x. Okay, so it means uh, dy dx is dy du times du dx. Okay, dy du dx, this one already. This is du dx, while dy du is if this is y, so it means dy du is half 1 over u, or 1 over 2u. So it becomes 1 over 2u times u dx 1 minus 1 over sine squared x minus 1 over 2 u sine squared x, or minus 1 over u is cosine x over sine x times sine squared x. Okay, so it becomes this minus 1 over divide 2 cosine x sine x. According to trigonometrical identity, that 2 cosine x sine x is sine 2x. This is trigonometrical identity. So this fraction becomes 1 over sine 2x, or it is minus cos secant 2x. Let's evaluate this one. Part C, show that square root cotangent x is an integrating factor for this differential equation. All right. Let's see. Integrating factor of a linear differential equations first order like this: dy dx plus px times g equals qx. This is integrating factor of a linear differential equation first order. So this differential equations has integrating factor through this mu x equals e power integral px dx. Right? This is the integrating factor of these differential equations. All right. Now the differential equations, the questions is dy dx minus y cosecant 2x equals square root tangent x. Right. So this is px cosecant 2x minus cosecant 2x. So we are going to find this one integral. This one mu x is this one e power integral minus cosecant 2x dx. So we have to find integral cosecant, integral minus cosecant 2x dx. Firstly, I will find the trigonometrical identity of cosecant 2x. Cosecant 2x, it is 1 over sine 2x. 1 is cosine squared x plus sine squared x, while sine 2x is 2 sine x cosine x. And it is half times cosine squared x over sine x cosine x plus sine squared x over sine x cosine x. Half times this is divide cosine x over sine x. Divide as well sine x over cosine x. Wait. Okay. I have a problem with my mouse. Now, this is half times, this is cotangent, and this one is tangent. Okay? So it's half times 1 over tangent. Cotangent is 1 over tangent. It is tangent. I would like to change, becomes a fraction with tangent is the denominator. So it becomes tangent squared x over tangent x. Half times 1 plus tangent squared x over tangent x. So it is 1 times the numerator 1 plus tangent squared x over 2 tangent x. So this is cosecant 2x. Now it means integral minus cosecant 2x dx is minus integral this fraction, this expression 1 plus tangent squared x over 2 tangent x dx. Or it is minus half integral 1 plus tangent squared x over tangent x dx. Let t equals tangent x. So dt equals secant squared x dx. Secant squared x dx, it is same equivalent with 1 plus tangent squared x dx. So this integral minus half dt over 1 over t, or minus half minus half ln t plus c. Okay, let's continue. I'm going to continue here on this page. So integral minus cosecant 2x dx. You're going to continue from this part. It is half ln minus half ln t is tangent. This one ln tangent tangent x, okay, plus c. Or based on ln rule, it becomes half ln 1 over tangent x plus c, or ln ln 1 over supposed to be 1 over tangent power half, but I will write it like this. Sorry, I'm gonna write it like this. Ln square root 1 over tangent x plus c. Okay, and then becomes ln square root 1 over tangent is cotangent plus c. Okay, so mu x for integrating factor e power power integral px dx It is e power integral minus cosecant x, sorry, cosecant 2x dx. And the result of integral cosecant 2x dx is this one, e power ln square root cotangent x, or based on a rule of e number, it is square root cotangent x. So the integrating factor is this one, cotangent x. Next, question part D. Hence, by solving the differential equation, show that y equals x square root tangent x. Okay, part D. The differential equation dy dx minus y cosecant to x equals square root tangent x. Okay. Uh, I'm going to multiply all terms with the integrating factor. The integrating factor is square root cotangent x. So it's going to be dy dx cotangent x minus y cosecant to x cotangent x square root tangent x times cotangent x. And for the next step, at the left-hand side, this side becomes the derivative of y and mu x. This is the derivative of y and mu x. This one, derivative of y and mu x. This is mu x, the integrating factor. So cotangent x equals square root tangent x cotangent x. Okay, this is the step of uh, differential equation first order, right? And after that, uh, make integral with integral, so integral also, and the left hand side becomes integral d y square root cotangent x. This integral becomes square root tangent x cotangent x dx. This dx becomes here. Okay, and after that, it's going to be this integral becomes y cotangent x because dy dx becomes y. Integral dy, I mean dy integral dy, of course, is y plus c plus, and the x already moved here, and this integral is tangent x times cotangent x cotangent x. It is 1. So this is integral 1 dx becomes y cotangent x equals, equals x plus c. X plus c. Now I'm going to substitute. I'm going to substitute y equals pi over 4 and x equals pi over 4 into this equation. And this equation becomes pi over 4 square root cotangent pi over 4 plus c. Okay, this is pi over 4. Right. Cotangent pi over 4, it equals 1. Okay, and then pi over 4 plus c. So c equals pi over 4 minus pi over 4, 0. So c equals 0. Now let's return into this equation, this one. Y square root cotangent x equals x plus c, this equation. And c equals 0, so it means becomes y cotangent x equals x. Y equals x over square root cotangent x, or x over square root cosine x over sine x, or x over cosine x over sine x, square roots, or x times square root sine x over cosine x, or y equals x square root sine x over cosine x, or x square root tangent x. So prove that y, better here, y equals x square root tangent x. That's E. Let's see, look at the question. Consider the curve y equals x square root tangent x for this x interval 0 to pi half, and the Euler's method approximation calculated in part A. According to part A, that the result for y is 1.98, right? If x 5 pi over 12, find the y coordinate at x equals 5 pi over 12. Give your answer correct to 3 significant figures, right? And we are going to compare the result of y in part A and the result here. Right. Part E. Y equals x square root tangent x. So yeah, with interval 0 to pi half. So if x equals 5 pi over 12, y equals 5 pi over 12 times tangent 5 pi over 12. And it becomes 5 times pi in radians over 12 times square root tangent. This is pi in degrees. And if you calculate, the result will be 2.5 5278, so on, rounded to 2.53. Right. This the result of y, the values of y. E part 2 question. By considering the gradient of the curve, suggest a reason why Euler's method does not give a good approximation for the y coordinate at x equals 5 pi over 12. On part A, we already calculate y equals 1.98 when x equals 5 pi over 12. You may evaluate the result on A. Now we're going to suggest the reasons why the Euler's method does not give a good approximation for y coordinate at x equals 5 pi over 12 on this graph, on this function, this graph, right? I have sketched, I have create the graph, and I will sketch here the graph. Right. Part 2. Yeah. The functions is y equals x square root tangent x. If you calculate at x equals 5 pi over 12, y equals this one, 2.53. Okay. And how about the gradient? The gradient is 2.53 over 5 pi over 12. Okay. 5 pi over 12. And the result is, I have calculated this, 1.93. And at x equals 4 pi over 12. Okay. I will sketch first the graph. On Cartesian diagram, x, y, I have sketched the graph. The graph like this. Okay. So this is by half on x-axis, and this is 0. Recall that the integral from the interval from 0 to pi half. Okay, this graph, this is actually the straight line. The straight line. downwards. Okay. Okay. At x equals 5, sorry, x equals pi over half, over 2 here. Okay. It's the interval. And look that uh, this strike line, the graph becoming less and less to 0. Okay, decrease. Okay, at x equals 4 pi over 12, y will be, I have calculated also this, y equals uh, 1.38, and the gradient 1.38 over 4 pi over 12. Okay, and it is 1.312 at x equals 3 pi over 12. Okay, y uh, equals 0.785. I have calculated this already, and the gradient is 0.785 over 3 pi over 12, and the result is the result, sorry, this is, oh yeah, 3 pi over, and the result is, this is 0.7785 also 1. Okay, so if you look the gradient, the gradient decrease the result. So for for this part, okay, for this part, if x, wait, at x equals 5 pi over 12, look that the result is 1.93. Yeah. And the gradient is uh, it is very large. Okay, right. But for me, okay, for me, when my suggest for my opinion about these questions is when 5 pi over 12, when x equals 5 pi over 12, uh, if we compare, okay, if we compare the result, on part A, on part A, yeah, okay, on part A, y equals 1.98. Okay, while on this one, on this part, y equals 2.53. Okay, if you look one, compare this one, okay, and the gradient will be large. Why? Why the gradient will be large? Because y equals 2.53. So it implicated for the gradient. Okay. And yeah, so the gradient, if you compare with the next result, the gradient. So the gradient changes from one from 1.93 uh, substance uh, substantially from 1.93 to 1 substantially con be sorry to rewriting this yeah becoming less and less, okay, from 1.93 to 1. Okay, next. This is part 2 and then part 3. The question. State why this approximation is less than the y coordinate at x equals 5 pi over 12. Okay. Right. If you part 3, if you look the diagram like this, y, x, okay, this is, well, that's not actually this one, pi half, 0. Right. Why this approximation less than 2.53, okay, less than 2.53, because the numerator, if you look the numerator y, okay, because the numerator, okay, because on, yeah, this is on concave, okay, on concave up curve, the numerator, okay, the numerator more and more becoming less. Okay, becoming less. So that's why if the gradient will be uh, different if you compare with the approximation when x equals 5 pi over 12, or only here the position as well 4 pi over 12 here, and then 3 pi over 12 around here. If you compare the gradient or compare the values of y of each x, the y values are becoming less and less. Yeah. So implicated for the approximations of the result, approximations of y. Why? Because on concave curve, if you calculate uh, the values of y based on based on the values of x, y will be more and more less because the values of x are becoming less and less. Okay, so if you divide, sorry, the values of y becoming less. Yeah, if y becoming less, if y becoming less, it means the gradient also will be less, the values of gradient. Yeah. Okay, I think this is clear if you compare the numerator. Next, part F. If I'm not mistaken, the last question is part F. This one. Okay. By considering dy dx minus y cosecant to x equals square root tangent x, deduce that the curve y equals x square root tangent x has a positive gradient for x interval 0 to pi half. Yes, of course. Because if you look the graph, we can conclude that it is positive, the gradient. Okay. So dy dx equals y cosecant 2x plus square root tangent x, which is y equals x square root tangent x. Okay. So if we substitute y into here, into this term, dy dx will be x square root tangent x cosecant 2x plus square root tangent x. On the interval x 0 to sorry, pi half, I mean, not 2 pi half. Okay. Now, we are focused on cosecant 2x and square root tangent x. Okay. If you substitute all x between 0 to pi half into cosecant 2x or tangent x, all values of y, all values will be positive. Yeah, I have calculated that. Again, if you, better writing here, if we substitute all x values of x between 0 to pi half, the results are positive. Okay, are positive. All right. So uh, it means also y will be uh, positive. Okay. And also y are positive. Okay. If x positive, the implications for y also positive. Okay. So It means yeah. Also, we can evaluate through the graph. So if y positive, x positive, gradient of course will be positive. If you look at the graph, y x, okay, and the graph like this, it's supposed to be like this. The graph is straight line here, let's straight line like this, and coming like this. That's one. And this is pi half. This is 0. So if you look on this graph, this gradient, the gradient, the gradient, the gradient is positive. Yeah. So if we there are two uh, there are there are two ways how we state that the gradient is positive. The first one through the values of x and y, and the second through this graph. Okay. Both of these ways show us that the gradient of these equations always positive.